guys? Today it's raining, and I just thought I'd do a quick recap video on some of the stuff I've been learning about SQL and databases. Just a quick little recap conceptually of like what I've been learning, and I thought I'd share it in kind of my own terms here. So, essentially, what is a database? So, a database is essentially like a centralized location for data. So why would that be important? So imagine if you have like different departments or like different sections of your business, or maybe like different countries. They're all like, maybe they have like a similar data, but they're you basically have to query or like ask for this data over and over again. There's no good way to update all the data, and since you have all these different points of contact, then it's hard to update. So you might update somewhere, and then it's not getting reflected somewhere else. So if you have those types of records and they're not being updated in a centralized location, then there's a big chance that this data is either malformed or not useful or out of date. So databases, particularly relational databases. And what is a relational database? Let me draw that right there. So a relational database is essentially a table. So let's imagine this. Okay. So let's imagine this as a table, right? So let's say you have some ID here. Sorry for the crappy squiggles, but okay, just imagine this is an ID. And actually, just to make it easier for myself, I'll just do like this. So you have ID here. And why is that ID important? So on a particular table, it's important because it helps you identify a unique name or serial number, or just a unique sequence of characters that identify that particular row. So if you kind of think about it like an Excel or Google spreadsheet, a row is essentially a horizontal line of data. This is also, I believe, known as a record. I might be wrong. I will try to update the video on Wednesday if I get that wrong. And you have columns too. Columns all have the same data, right? So this ID right here, just say like name of, I don't know, space station. Let's have that be one of them. So boom. So that's one of them. We have ID. So let's say one of the IDs is let's say one of the IDs just has a simple number like 1, 2, 3, right? And let me bring that back to ID. ID, right? And then let's say name a space station. That's going to be like something like NASA Houston. So we'll have that be one of the names. NASA Houston. So essentially, you in every different column of data, they have a different type of data. So ID, that can be like all numbers of certain length. Name of space station could be a string. You have booleans, which are essentially true or false. You could have enum, which is essentially different statuses. And why are these relational databases important? It's because you can do a lot of great things with set theory, which is some of the type of operations you do there, and then relational operations as well. So within the centralized database, all this data basically has a single source of truth. So let's imagine you just have people, which will represent as circles. So all these different people can essentially access the database and have the same, let's say, price information, same location information, have query information on the ID. So we're essentially allowing this single source of truth and access to different people. Obviously, these people have different access levels, but the great power of a relational database is, let's say, this table right here. Maybe you have a second table. Oops. Right? So let's say you have a second table. Okay. So let's say let's put it here. Paste. Okay, let's put it right there. So let's just say instead of space station information right here, you have like government agency, right? So let's do like government agency right here. So maybe you have like the FIA here, government agency. I might have spelled government wrong, but we'll see. And then let's just say like FIA for like the, I think it's like the Flight Institute or something. It's not really important, but let's say you want to combine data. So like here, not only have the name of space station, government agency, but you also have like the current funding, right? So let's put that right there. So one of them, let's just say they have, I don't know, like $1 billion that can be allocated. Or let's just keep it a simple number. 1 billion dollars, and then we'll just have that be like the fiscal year budget. So the great thing about relational databases is you'll have different tables. So for example, this table data is name of space station, probably other space station details and attributes. And here you have more government information and attributes. But if you have a primary key that has like that unique value, you can combine these tables into one table. So you can actually connect these two pieces of information with a join right there, and then create one big table. Besides that, another very important thing about relational databases is, essentially with these tables, you can essentially do, I think it's relational operations. So you can do unions, differences, intersections, and a lot of different joins as well. So there's a lot of power in having all this data in a central location, but also being able to do operations to select data in particular with particular filters, and basically being able to manipulate data in certain ways. So the great thing, if you think about like an Excel spreadsheet, you're almost able to manipulate and transform the data similar to like a pivot table and have it be really useful for you. I won't be able to show you in this video, but most likely probably on Wednesday's video, some ways you can use SQL, the structured query language, to be able to access information on a database. So we'll play around with some like better fake data. I'll have it better structured, and then potential ways you could query and filter that data. But in a nutshell, all database is a centralized source of data information that users can essentially do relational and operational relational and operational functions to basically manipulate the data, filter it, and basically return that data in a useful manner to that end user. And you can do that for those operations and the SQL query language. So, and then the other thing is like columns, they'll all be vertical, they'll have the same data type. Rows will essentially be a record with a collection of different data types and denoted by some unique primary key. It's usually the ID, and that primary key can be used to combine different tables of data in a join query. So kind of just some of the simple stuff I've learned today. For me, I'm still kind of consolidating or like better understanding the concepts. So over time, I'll be able to better explain this. But thank you guys for joining, and I will see you guys on Wednesday's video. Cheers.